Okay, good morning everyone. Our class today would be on stack, this stack. So when you see stack, you imagine this stack of books. So you put book 1, book 2, book 3, and then you put an apple. Okay, so if you were, okay, ignore the apple, ini book 1, book 2, book 3. So this is what we call as a stack, right? The concept of a stack. Alright, a stack is a type of a data structure. It is based on the principle of last in, first out. Contohnya, when you put this book, first is this book, second is the book, this book, third is this book. So the first book that you pick up is the last one. So that's why it is called it's based on a last in, first out principle. Is that clear? Okay. Our learning objective is to learn about stacks. So basically how you create stacks, what are the implementation that you can use. Stack is a data structure. But how can you implement it? You can implement it in two ways, using array or linked list. But array, the size is fixed. Linked list, the size can be infinite, right? Because you can allocate and deallocate data. And then you're going to look at what various other stack operations. For example, how do you populate the stack? Meaning you put in the data inside the stack. That is called the push stack. Okay, you take out data, it's called the pop stack. Then you can check whether the stack is empty or not. The list is empty or not. Is it full or not? Alright. Then we're going to look at how to implement a stack as an array. We're going to look at how to implement stack as a linked list. You must know the difference between implementing stack as an array and linked list. Array, size is fixed. Linked list, the size is not fixed. It can be dynamic. Okay. Then you can look at the application of stack application. Alright. For example, when you use Word, right? Word, then you type, and then you can undo. That one is stack lah, because the last thing that you type tu, you boleh undo. Alright? You tekan control Y, I think. Nanti kalau you dah buang, boleh control Y to undo the action. And then you're going to see how to use stack to remove something from the stack using retention technique. So this is an example of a stack. Stack of coins, trays, boxes, books. This is the implementation lah. Alright, but the concept is stack. It's called a stack. Okay. So how do you remove the book applied math? You just take this one first out. How do you remove the book world history? You have to take out applied math first, then only you can remove world history. So that's why it's called the principle of last in, first out. So stack is a data structure. It can be implemented in array and linked list. Alright. All stacks, array, linked list can hold a sequence of elements. That is one lah. For example, number 1, 2, 3, 4, 5. Alright. It is based on the concept of last in and first out, LIFO structure. Alright. But the thing is, you see, this stack, right? Everything must occur at only one end, called the top. Top tu dia macam the portal where everything happens lah. So it happens at the place called the top. So you put in data, happens at the top. You take out data, also happens at the top. So this top is like one of the main engines lah inside the stack. Okay. Any questions so far?
No, sir.
So far, okay.
Yeah. All right. Just in case if I miss anything, can you guys ask me in chat? Just in case kalau I tak dengar you punya suara, ya. Okay. Now this is the additive of a stack. You can initialize a stack. Okay. You can check whether a stack is empty or not, whether the stack is full or not. You can push data inside the stack into the stack. You can take out data from the stack using a pop, or you can retrieve the top value of the stack, which is the top. So everything push pop happens at the top. Alright, the top is where everything happens. So if this is a stack, okay, push pop is here. It happens through this top here. So imagine like here you've got data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whatever happens must happen at the top. You push data at the top, you pop also from the top. Okay. So pushing is basically adding a new element into the stack. But you can only add element into the stack if the stack is not full. So there's a precondition for push. Now, to retrieve the top operation of a stack, okay, the stack must exist. Basically, to perform push, top, and pop, the stack must exist. But for top, the stack must not be empty. Okay. So if you perform top, you get the top element, but you don't remove it. If you perform pop, only you will remove the top element of the stack. Right? In order to pop, the stack must exist and it must not be empty. If you want to throw something, it has to exist lah, and then it must not be empty. If it's empty, then what can you throw? Same with push. Alright. If you want to push something inside the stack must exist and it's not full. For top, you retrieve the element only. So you want to retrieve a data, that the data must exist inside the stack and it must also not be empty. So some other operations is to check whether the stack is full. Alright. If it's full, return the value true. Otherwise, return false. And then when you check whether the stack is empty or not. Right. So this one is checking full stack. This one is check whether the stack is empty. If the stack is empty, it will return true. Otherwise, it will return false. And then initialize the stack. Basically, stack becomes empty. How you initialize the stack to become empty? That one we'll learn later on. Okay. Any questions? No questions there? All right. So we're going to look at implementing stack ADT. We're going to look at push, pop, top also actually. Not written here, but we're going to look at top as well. All right. So when you want to implement the stack, you can implement it using an array or linked list. But there is a difference between these two. All right. Array, size is fixed. Linked list, the size is dynamic. All right. It can keep on going because you can keep on adding the data inside the memory or the heap. But that's the theoretical part lah. But of course, the physical constraint is the memory size lah. Okay. But theoretical, you can keep on adding data. All right. Now we're going to look at how to implement stack using an array. First stack element you put in the first array slot. Second stack element you put in the second slot. Then the top of the stack is the index of the last element added to the stack. Alright. So now if you notice, if you implement it using array is a random access data structure. You can access any data inside the array by referencing the index. Remember? A1 or A6, you can get the element straight away. But the concept of stack, everything push pop must happen at the stack top only. Alright? So everything must happen here at the top. Stack top here. So this top guy. But array index you can randomly access, right? So you need a place, alright? So you need a variable called stack top, alright? To keep track of the top position of the array. So when you implement a stack, okay, using array implementation, you must have the variable stack top because everything will happen at the stack top. To push data happens at the stack top. To pop data also happen at the stack top. So this is the data for stack implementation, maximum stack size, stack top, and the list of data. Here are the basic operations that you can perform. Initialize the stack, check if the stack is empty or not, is the stack full or not, push data inside the stack, get the top value, top of the stack, pop the data of the stack, copy stack, alright? And this one is the destructor of the stack. And then you're going to have the constructor of the stack as well, alright? So, if this is an array, stack, okay? So stack is an object of stack type. Alright, so this is an object of stack type. Now, stack type has the maximum stack size. Alright. The stack top value and a pointer to where of the array. So the list here holds a pointer to the array that holds the data for the stack. Alright. Now, the value for stack top can range from 0 to the maximum of the stack size. Alright. If stack top is not 0, then stack top -1 is the index. Okay. This -1 is not the element, but is the index. So here stack top is number 3. Stack top here, 4 here, basically says there are 4 elements inside here. Alright. Stack top -1 is the index for this top of the stack, which is 3 lah. Right, so 4 minus 1 is 3. So how do you initialize the stack? Initialize the stack. So this when you initialize the stack, this is the maximum stack size. But the stack top, you must say element inside the stack. In the stack. So these 2 points are very important because they represent different things. -1 gives the position. Stack top is the number of elements inside the stack. So when you want to push, okay, stack top is 4. Alright. So when you want to push, this one is before pushing y. When you push y, stack top becomes 5. Because there are 5 elements. 1, 2, 3, 4, 5. The index is 5 minus 1, which is 4. Okay. The implementation is, okay, if you want to add item inside the stack, you must make sure first you check the stack must not be full. If it's full, then you have to tell the user you cannot add in to the stack anymore. Alright. If it's not full, list stack top. Okay, this list, the stack top, okay, you're going to put in the new item. Letak ada satu nombor ni, katakan 5 kan, you akan increase the stack top value by 1. So, the next time you masuk this particular function, you can immediately less stack top, you just assign to the new item. Okay. So, here, stack top 4, okay, then you tambah the new item, then stack top becomes 5. Alright. Tapi if you look at the code here, be wary of this one. List stack top. Okay, if stack top is, say for example, it's 4. if this list is stack top here is 4, then you're going to put in the new item. Then this 4 will become straight away 5. So the next time you panggil this particular function, list stack top here, the value is 5, terus you masuk in the new item. Okay. For push, okay, you have to check. Okay, so this one already I will explain lah. You must make sure that you have to check the stack is full or not. Okay, if it's full, then you tell the user. Another way of writing this is that you use, another way of doing this, you can check, you can use this particular command. If stack is full, okay, you use function stack.push new item. Alright, so this one here. So this is also basically this one here. Okay. Hello? Can anyone hear me?
Boleh sir,
Yes,
boleh.
can hear.
Yeah, okay. Alright. Was quiet. Alright. So here, basically you check if the stack is full or not. Alright. If it's not full, then you use stack.push and then you put in the new item here. So it calls the stack push new item now, right? This particular function. So everything push happens at the stack top. Okay. When you pop, also it happens at the stack top here. So if this stack top 4 element, the index refers to 4 minus 1, which is 3. So when you pop here, the stack top value decreases into 3. So meaning only 3 element, the top index will be 3 minus 1, which is 2. Alright. So same with push, the pop you must check if the stack is empty, then you cannot delete anything. Alright. So you have to check if stack is empty. If stack is not empty, you can proceed. But if stack is not empty, then you have to tell the user you cannot remove from an empty stack. How do you remove an empty stack? Easy. Stack top, you just minus 1 because it goes 1. Everything has to happen at the stack top. So 3 minus 1 becomes 2. So stack top is minus 1. Alright. So you can, this is called, just now is overflow, this is underflow. You check if the stack is empty, then you cannot remove anything from the stack. Okay, alternatively, you can use stack.pop. Now, how do you want to return the top of the element? Okay, so gonna learn this new function called assert. Assert, if this condition is true, it proceeds to the next line. If this condition is not true, then it will terminate the program. So it checks. You want to return the top of the element, it checks. Is stack top the same as 0? If stack top is it checks if stack top is not the same as 0. If it's not the same as 0, then it will return the value of stack top minus 1. So you get the element that is indicated by the stack top minus 1. However, if stack top is equivalent to 0, it will terminate the program. So that is the function of assert. Right? So assert means if you fulfill this condition, proceed. If you don't fulfill this condition, terminate the program. So for other function for stack in array, you can try copy stack, constructor, destructor, and overloading of assignment. This one you can review inside your textbook. We're also going to do it in our lab as well. Okay, so please have a look at your textbook and then do your lab. Yeah. So this is DO notation, the time complexity for stack operation. So this one I think you can go through by yourself. Yeah. Assignment operator. It depends on the value of n. How many items inside the stack you're going to copy. Others are all the same, the complexity. Any questions?
So far, no. Still digest.
Okay. So I think array is this one implemented of stack is quite easy actually. Right? It's based on array. Just that this or not. Okay, if there's empty, nothing to pop. If you want to push, make sure it's not full. If full, you cannot you cannot remove. Easiest is pop lah, because you just minus the value for stack top. It's very straightforward. Okay, so stack is a very easy subject, easy chapter. So make sure you score if the question goes inside your midterm. Now we're gonna look at implementing a stack using linked list. Okay, this one a little bit hard, but still overall very easy as well. You need to master the concept of linked list, especially on how you want to create a new node, and then you want to add into an existing node, and then how you want to delete item from a linked list. This one you must master. If you can master that, this this chapter for stack very easy. So if we implement it using a linked list, the size is dynamically allocated and deallocated. All right. Array, the size is fixed. All right. So just now you got fixed, like this one. See, max stack size you dah tahu 100. This one linked list tak ada. All right. Okay. Now linked list got so many types. So singly, doubly, circular linked list. So the concept of stack, you add in data, and then you can take the data out based on the last one that was added into the stack. All right. So which linked list can you apply? So since you don't need to move front and back, you can just use singly linked list. All right. To implement stack. Clear? Singly linked list is a normal linked list basically. Now, the array, the difference between stack top in an array and linked list. In stack top, alright, stack top is basically indicates the number of elements in the stack. Alright, stack top minus 1 is a points to the top item in the stack. That's in array. But for linked list, it gives you the address of the top element of the stack. Right, the memory location, the address. The address is basically the memory location lah. Right? Because you're using pointer. Now, when you implement a linked list, okay, to when you use linked list solution, all right, to implement a stack, inserting at head or end doesn't make any difference. Both are equally efficient. However, if you want to remove an element, it's better to move it from the head. All right, because why? If you remove it from the end, you have to traverse the list from front to back to delete the last one, because the concept is last in, first out. Alright. So if you want to remove it, then that means you have to traverse the list from 8, 1, 2, 3, 4 sampai you go to the last one, then you buangkan. But if you put it from the head, I mean if it's from the head, alright, it's better approach, because terus you jumpa, you buang or you tambah. So you see, this is an empty stack top. Stack top means pointing to null. Here is stack top pointing to a non-empty stack. So it points to the first node. Okay. Last in, first out. Alright. So you see, this guy here, the last node, the link points to null. So a default constructor for a linked list implementation, stack top points to nothing. So points to null lah. This one. Now, a stack is never full. Alright? Because you can keep, theoretically, you can keep on adding data inside it. Therefore, when you use full stack implementation to check whether the stack is empty, it will always return false. Because the stack would never be full. You can keep on adding data. But can the stack be empty? Yes. So how do you know it's an empty stack? Stack top is basically oppose the value none. So here stack you return the value of stack top, is it equivalent to none? Alright, so if it's none, then it's return true lah. Alright, so this is an empty stack. Stack top points to nothing. Okay. Any questions so far?
So far,
Guys,
no.
no question. All right. Okay. So how do we initialize a stack? Now this one initialize a stack more work compared to array, because why? The stack you need to say everything is empty. Not array is simple. Initialize stack, you just put stack top to what? 0 is now. So you see this guy here, initialize. What's it? You want to initialize simple, stack top you put to 0. Array very easy. But linked list, little bit harder. Because why? You must make sure nothing inside the stack. Okay? So, when you initialize the stack using linked list, you must make sure it is into an empty state. Alright? Because a stack might contain elements. Alright? So, if you want to initialize the stack, you must make sure that all the data is to be deallocated. Okay, any memory that is occupied by the stack must be deallocated, and then you set the stack top to null. So this one is the last thing that you should do. First, you should deallocate all the data first. So here is to initialize the stack. We're going to create a pointer called temporary. As long as stack top is not null, temp is going to point to whatever stack top is pointing to. And then stack top, you're going to move to the next node, and then you're going to delete them. Right? So basically, you're going to keep on deleting until stack tops become null, which is this one here. Alright? So you delete until stack top becomes null, only then it's considered as initialize. So how do you push into a stack top? Alright? You need to check, is it full or not? Now, stack top, if you want to push a value inside the stack, alright? Now, it's supposed to be infinite. I mean, you can just put in the data. Alright? Of course, the constraint will be your computer memory lah. But theoretically, you just can put in the data. Because you see, for stack implementation, the size is actually, you can keep on adding the data. Alright? This one here. Okay. So when you can keep on adding the data, what happens is that if the stack is full, it will always return false. Okay? So here, when you want to push something, you don't need to check lah actually. You look at the code here, it's nothing but checking whether the stack is full or not. Alright? So when you push the data inside the stack, you create a pointer, points to a new node, you put in the data. Now, you need to link this new node to this node. How you link it? New node link is going to be assigned to the value of whatever stack top is pointing to. So you establish this. Right? And then you move the stack top to whatever the new node is pointing to. Go back up. So you get this. So the code here, create a new node. Okay. Create a pointer. The pointer points to the new node. Put in the element. Right? And then the new node link is going to be pointing to whatever stack top is pointing to. And then stack top is going to point to whatever new node is pointing to, which is the new node that you just created. Alright? So you don't check whether the stack is full because logically the stack is never full. How do you want to return the top element of the stack? Very easy. You check if the stack top is not null. Okay, then you proceed, return stack top info. Like this. See? Stack top is not null. So how do you get the value? Stack top info. Finish. That's all. That's how do you pop data from the stack top. Very easy as well. So if you want to delete C here, you're going to introduce a pointer called temporary. Alright? So what happened is that this stack top now, you need to move it to B. So how do you need to move it to B? Stack top is assigned to the value of stack top link. So stack top goes down here. And then temp goes to here, then you can delete temp. So you end up with B and A. Because it's based on the concept first in, last out. So you get this particular code here. As long as stack top is not null, temp is going to point to whatever stack top is pointing to. Stack top is assigned to value stack top link, delete temp. Else, you cannot remove from the empty stack if stack top is null. You don't have this when you want to push. You only have this when it's going to pop. Because when you want to pop, you must make sure that there is something inside the stack. So these are other functions for stack, copy stack, constructor, disruptor, and override loading assignment operator. You can have a look inside your textbook, and then we're going to textbook, and then we're going to cover it inside the lab as well. Alright, same. This is the before notation for linguistic implementation. Alright. Any questions so far?
No questions so far.
No question. Alright. Okay. Now we're going to look at a non-recursive algorithm to print a linguist backward. Okay. So you're going to use linguist implementation of a stack, okay, to print a linguist backward. Okay. So first points to this node 5, 10, 15. So what it wants you to do is print 15, 10, and 5. So what you're going to do is you're going to introduce a pointer called current. Current is going to point to whatever first is pointing to. So it points to this guy here. First point to 5, current points to 5. As long as current haven't reached to null, stack push current. Okay? And then current is going to be assigned to current link. So if points to 5, push 5 current here into stack push, and then current is going to be moved into the next node. Alright? So here, if you look at this, okay, current points to 5. Okay, to bring that into push coding here, okay, which is current. So new node link. So the data is 5 just now. New node link is equivalent to whatever stack top is pointing to. Alright, and then stack top becomes is going to be assigned to whatever new node is pointing to. So stack top currently points to nothing. Alright, so current, you pass current to push, then stack top is going to have the value 5. Okay, you push this one, then stack top is going to point to 5. And then after you do this one, current is assigned to the value current link. So current from here move to 10. Okay. When current move to 10, again put 10 inside and then move to 15. Okay. Now, while current is not null, after 15, then current is going to be pointing to null. Okay, so basically it doesn't fulfill this condition anymore. Alright. That one is you put the values inside the stack. You put the values inside the stack. Okay. Now, if you were to get the stack top, you're going to say current is equivalent to stack top. So current here is going to point to the stack top. Okay. And then you're going to pop the data. When you pop the data, you're going to pop 15, 10, 5. Alright. So you get this one here. Current points to stack top. Stack top. Alright. So when you pop, you're going to, since current points to the stack top, and then you pop it, alright, you're going to see out current info. Alright, so you're going to get 15, 10, and 5. And this will be repeated until the stack is empty. So basically what it does, put this data, but put 15 first. Then you put 10, then you put 5. Alright? Oh, sorry. My mistake, sorry. You put 5 first, because current points to 5. So you put 5, 10, 15 inside the stack. So you put 5, 10, 15 inside the stack, and then you pop out from the top. Alright, so you get 15, 10, 15, and 5. Alright? So you are able to clean it backwards. Any questions?
No.
No. Okay, if no
No,
question.
sir.
Yes, hello? Any question just now? Tak ada, eh?
No, sir.
No, okay, alright. So this is the STL template library lah for stack. Alright. So check empty as the stack is empty or not. Push, top, pop, and the stack, the size stack. So this one we already covered. So by now you should know what LIFO means. Alright. Please make sure last in first out it happens to the stack top. Alright. What element is retrieved from a stack by the pop operation? Right? Basically the item that is at the stack top. Describe two operations that all stack can perform. Push and pop lah, easy. Alright, any questions? Okay, no questions. That's all for today. I'll see you during your lab class. So this class has is more towards implementation. So your lab is going to be you're going to get more understanding when you do your lab. Okay? So the lecture will be theoretical. Your lab later on you can see how you implement the linked list, implement stack. Alright? Any questions, guys?
So far, no.
Okay, if no question, that's all for today. Remember, your midterm, please give me feedback by Friday, Wednesday noon. No feedback from you guys, I will proceed with the the midterm date and time that I propose. Okay? Alright.
Sir.
Thank you, everyone. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.